Hi everyone. So let us discuss this example of double integration. So in this example we have an integral and they have asked to change the order of integration. Okay, what is meaning of that? That means if the given strip is vertical, we have to rotate it and we have to make it horizontal and then we have to solve the problem. Or if the given strip is horizontal, we have to rotate and make it vertical and then we have to solve the problem. Okay, so let us start to do. What will I do? First of all, I write the given integral. Already I have written here. Okay. So see, this is equal to integration 0 to 2 integration y by 2 to 1 e raised to x square dx dy. See, y by 2, that means y is involved here. So that means it is a function of y. So I'm writing x is equal to, obviously here x is equal to, when we have a function of x here, we have to write y is equal to. So that means these are limits of x. So obviously these are limits of y. So y is equal to 0 and y is equal to 2. These are limits of y. Okay. So that's why I can write, therefore given region is bounded by, okay, I will mention all these curves. X is equal to y by 2, next x is equal to 1, next y is equal to 0 and the last y is equal to 2. X is equal to y by 2. See, power of x is 1 and the power of y is also 1. So that means it is equation of straight line. So I will simply mention it is a line. So you know well how to draw or how to find the given line. What we do when we have an equation of line, we draw a table, okay, having 3 rows and 3 columns. So first x, next y and the last one is xy. We are interested to know any 2 points on a line, okay, then we join the 2 points by line and we get a required line. This is our technique. So yeah, we have a full freedom of putting any points. So I am putting x is equal to 0. If I put x is equal to 0, obviously the value of y will be 0. So y is equal to 0. The first point we have got 0, 0. After that, normally what we do, after putting x is equal to 0, we go for y is equal to 0. But what will happen in this case, if I put y is equal to 0, we will have x is equal to 0. That means again we will have a same point. So to avoid it, I will try with some another number. So I am putting x is equal to 1. Okay, so I am putting x is equal to 1 here. Obviously we'll have y is equal to 2, since 1, if you shift 2 here, 2 into 1, 2. So the point is 1 comma 2. That means this line passes through these 2 points 0, 0 and 1, 2. So I will draw the diagram here. Okay, see, this is our y-axis and this one is our x-axis. Okay, y-axis and x-axis. Here 1, 2, minus 1, minus 1, 1, 2. Okay, the first point is 0, 0. So that means here 0, 0. Getting? The second point is 1 comma 2. 1 comma 2. Point is here. Okay, so 1 comma 2. I will write somewhere here 1 comma 2. So that means given line passes through these 2 points 0, 0 and 1 comma 2. That means the line will be like this. So this is a given line. Okay, I will mention x is equal to y by 2. Okay, see, next x is equal to 1. X is equal to 1. This is a line, getting line parallel to y-axis. X is equal to 1. A line parallel to y-axis which passes through x is equal to 1. So that means the line will be like this. So this is x is equal to 1. So obviously it cuts y at point 1 comma 2, since this point lies on this line. Okay, so x is equal to 1. Next, y is equal to 0. As you know, this is equation of what? X-axis, y is equal to 0. So this is y is equal to 0. Third line also we have got. And the next one, y is equal to 2. So y is equal to 2 is a line parallel to x-axis, okay. See, y is equal to 2, a line parallel to x-axis passes through y is equal to 2. Y is equal to 2. Okay, so all these lines we have got. So the region bounded by all these lines. So maybe you will get confused which region we have to consider, this region or this region. So what we do, see, the inner integral is integration with respect to x. Getting now the inner integral. This is outer integral, this is inner integral. So this is integration. These are limits of x. So that's why inner integral is with respect to x. That means the given strip is parallel to x-axis. Okay, given strip is parallel to x-axis. So our strip is bounded below by this line. So if you consider strip here, okay, so in that case you cannot say the strip is bounded below by this line. But if you draw a strip like this, if you consider the strip like this, then definitely it is bounded below by this line and bounded above by x is equal to 1. You are getting my point? What I am saying, if I draw a strip here, for example, if I draw a strip here, so here the strip is bounded above by this line, but by the given information strip is bounded below by this line. So that's why strip cannot be here. You are getting my point? Okay, so strip should be here. So that means this region we have to consider. So this region I have considered. Okay, so now we will follow the instruction. That means in given problem they have mentioned change the order of integration and then solve the problem. So for that purpose, what will I do? I will consider a strip parallel to y-axis. Okay, I will mention clearly here to change the order of integration. To change the order of integration, we consider a strip parallel to parallel to y-axis. Okay, what will I do? I will draw a diagram here in which I will consider a strip parallel to y-axis. So we have to draw the same diagram here. Okay, same diagram I will draw. Simply I will consider a strip parallel to y-axis. Okay, so see, this is a line, x is equal to 1. Okay, this is y is equal to 0, and so this is the line we have which is x is equal to y by 2, getting? And this is a line we have which is y is equal to 2, and this is a region again. Region is same, huh? There is no change in region is same. So simply we have to consider a strip parallel to y-axis. Okay, so because we have considered strip parallel to y-axis, limits will change. So make a screenshot of it and after that we will go further. Okay. Okay, so see, we have considered a strip parallel to y-axis. So what is our technique? We always consider strip is bounded below, bounded above and left to right. Okay, so strip is bounded below by y is equal to 0. So first of all, y varies from 0. You know well, that means when we consider a strip parallel to y-axis, we write first y varies from dot dot to dot dot, and after that we write x varies from where to where. Getting? So that's why I wrote this y varies from. Strip is bounded below by y is equal to 0 and strip is bounded above by this equation x is equal to y by 2. But we want y is equal to something. So for that purpose, I will shift 2 here and we will have y is equal to 2x. So we got limits of y. After that, we have to think about limits of x. Okay, what we do, we move the strip from left to right. Okay, so when we move from left to right, we always consider a point. Okay, what is the last point where it reaches? See, if you move a strip like this, so it will start at 0. Getting now? So size will, don't consider the size here. It will start at 0 and it will stop at x is equal to 1. So that's why limits will be x is equal to 0 to 1, right? So now our strip is parallel to, I will remove this part. Now our strip is parallel to y-axis, right? Parallel to y-axis. So that's why our inner integration is with respect to y and the outer integration is with respect to x, right? Here obviously we have to write limits of y. What are the limits of y? 0 to 2x. And what are the limits of x? Here clearly mentioned 0 to 1. Okay, so let us focus on inner integral. So inner integral is with respect to y. So whatever the terms of x, we have to consider those are constants and we will take them outside. So for that, integration 0 to 1, that e raised to 2x, e raised to x square is independent on y, its term of x only. So it is constant and I will take it outside. Integration 0 to 2x dy and dx. Okay, so this is equal to integration 0 to 1 e raised to x square. What is integration of dy? Obviously it is y, so it is y, and 0 to 2x dx. So this is equal to integration 0 to 1 e raised to x square. Okay, first I put the upper limit, after that I will put the lower limit. The upper limit is 2x and the lower limit is 0. Okay, dx. Now I will remove this diagram. Okay, these are not required now. Simply we have to solve this integration. That's it. Just a minute. Okay, so diagrams are removed. See, okay, I will solve here. So this is simply we have integration 0 to 1 2x e raised to x square dx. Actually, e raised to x, if e raised to x is there, we can easily solve the problem, but we have e raised to x square. The problem is a little bit complicated. So we cannot solve it directly just by using the formulas of integration. What will I do? I will use the substitution. Okay. So I will put something here to solve the integration. So that's why I am writing here, putting t is equal to, okay, but we need to take care of one thing. That means when we put anything, its derivative should be easily available there, getting? So that's why I will put t is equal to x square, because what is its derivative? Derivative of x square is 2x, and which is easily available here. So it is better to put t is equal to x square. So yeah, x square derivative to x dx. So when we put anything, okay, when we put anything, what we have to do? We have to find its derivative, and the second thing, we have to change the limits also. So let us focus on limits. So for what are the original limits? 0 to 1. So original limits were 0 for x is equal to 0 and x is equal to 1, and for these old limits we have to find our new limits of t, since variables is changed now. Okay. So for x is equal to 0, what will happen if I put x is equal to 0? T is equal to 0. Okay, and what will happen if I put x is equal to 1? T is also equal to 1. So therefore our I will simply call I. Okay, so now we are going to take new limits 0 to 1. Okay, e raised to x square, e raised to x square means t, so e raised to t, and 2x dx, see, 2x dx. So combinedly we can call it as dt. Okay, so now the integration is very simple, easily we can solve it. What is integration of e raised to t? Integration of e raised to t is simply e raised to t 0 to 1. After that we put upper limit, so we'll have e raised to 1 minus lower limit e raised to 0. E raised to 1 is e, and e raised to 0 or anything raised to 0 is always 1. So see, e raised to 1, so the answer is e minus 1. So the problem is over here. You can make a screenshot of it, and after that we will stop. Thank you. Bye.